Hello, Algebra Tours. All right, today we're going to talk about graphing radical functions. We call these radical functions our root functions. We're actually going to be talking about two different root functions today. We're going to talk about the square root and we're going to talk about the cube root. You're going to need your notebook, and yes, you're going to jot these down and give yourself the best graph you can, something to write with, and a calculator. So let's get started. All right, so on this slide, it's not necessarily all review, but maybe a little bit of review and a little bit of new stuff. We're just going to talk about the general shape of what it looks like when we graph functions like x squared. If you remember when we graphed our x squared functions, this is when we got our parabola looking shapes, or our u's. When we talk about our absolute value functions, again, we can't have anything negative come out of it, so this would be our v functions. Our y equals mx plus b is our straight lines. That's a linear relationship. Now the y equals x cubed, this is something we haven't necessarily talked about in Algebra 2, but these functions are going to look like such. They have two curves, kind of. They're like two parabolas that get mixed together. And then the y equals x to the fourth is kind of the same thing, but this time it has three kind of curves, and it looks something like that. So this is what all of our functions look like. Now the main reason to look at this is because today, again, like I said, we're going to talk about the function y equals the square root of x, and we're going to talk about y equals the cube root of x. So when we talk about these, we want to understand that, okay, well, this should be a similar shape, or it should relate a little bit to y equals x squared, and our cube root should relate to y equals x cubed. So in the next couple of slides, hopefully you can kind of put the two pictures together and understand where it is that we're getting those actual shapes of the graph. All right, so now when we graph and we use our transformations, we always talk about a parent root function and what that parent root function looks like. So we're going to compose that a little bit here. We're going to talk about both the square root and the cube root and the differences between them. And let's just go ahead and jump right into it. So if I talk about numbers that I want to fill on this table for x and y, if I pick a number, let's say -1 to plug into x here, that means under the square root I would have a -1. Hopefully you see there that that's a red flag. We can't have that negative number under there because that causes imaginary numbers. So we don't want to use any negative numbers when we're talking about that square root. So let's then, instead of -1, let's talk first with, let's try 0. If I plug in the square root of 0, the number I would get back then is 0. Let's then jump up the ladder and go to 1. Do we know the square root of 1? We do. That would be 1. Now we could jump up and we could go to 2, but when I plug in the square root of 2, we think about that, and that's not a whole number. We'd get back a number, but it's a decimal, so we don't want to use 2. Instead, let's think of a different number we could use to help us kind of get back a whole number. Since we're talking about square roots, the nice numbers we put under square roots to make them go poof would be our perfect squares. So the next highest perfect square after 1 would be 4, and when you plug in the square root of 4 into your radical, you'd get back the number 2. So I'm going to leave it at that. I'm going to have you just memorize those three ordered pairs, so 0, 0, 1, 1, and 4, 2. And from there, we're going to kind of manipulate that. Now, what does this look like in your picture? Again, we remembered that we don't have any negatives here. I can't plug in any negatives. So if you were to plug that into your calculator, you'd get back a picture that looks like this. Again, there's nothing to the left because I can't plug in negative numbers because they give me imaginary solutions. So when we talk square roots, it's kind of funny that we say, okay, a square root starts at one point and then it shoots off like a shooting star. So when we graph them, I always think square root all the way over to the right there. A lot of them do go to the right. Again, we're going to take this and we're going to move it all over the graph. We're going to flip it upside down. We're going to move it left. We're going to move it up. We're going to move it down. We're going to move it right. We're going to do all sorts of manipulations to this graph. So it might move over the place, but again, it's only going to go in one direction because we can't go to the left because we don't want imaginary numbers. Domain and range, then again, if we think about domain, this is my x values. This comes back from way in the beginning of the year, x values, and we read that left to right. So my most left point here would be 0. My most right point, since I have an arrow there, would be infinity. Now again, we remember that on infinity we can't close it, so we got to have an open bracket, but at 0 I'm going to have a closed bracket. Range then is my y values, and when we think about y values, we read those bottom to top. So my lowest point on range here, if we're thinking y values, would be 0. Highest point, again, it doesn't point up, my arrow doesn't point up, but again, remember, it's gradually increasing and going higher, so we are still going towards positive infinity there. Okay, so getting those domain and range values kind of jotted down because we'll talk about those a little bit further. And memorizing this parent table, okay? So for square root, we memorize 3 sets of ordered pairs. As we jump over to our cube root, then it's going to be a little bit different because the numbers I'm going to plug in aren't going to work the same if I chose the same set of numbers here. So we want to be specific. In a cube root, though, remember, we can have negative numbers. So let's start maybe with a -1. If I plug in the cube root of a -1, a -1 here, we actually get back the number -1. And again, because it's a cube root, I can multiply -1 times itself 3 times to get back that number -1. So it is a perfect cube when it's negative. The next one I'm going to try then is 0. So the cube root of 0 is still going to be 0. If I were to try a +1, then the cube root of a +1 does give me a +1. And the next number then I'm going to try, again, over here we used perfect squares because it was a square root. So when we talk about numbers over here with a cube root, hopefully you're associating that we now want to use perfect cubes. And you can find those perfect cubes on your perfect cube chart. And the next perfect cube higher than 1 would be 8. And if we plug in the cube root of 8 on your perfect cubes chart, or perfect roots chart, you should see that the cube root of 8 is 2. So again, on the other end of things, I'm going to use the negative there and get back a -2. So again, this table now is going to be the table you want to use when you are using your root functions for a cube root. So for a square root, you only have 3 ordered pairs to memorize, but for a cube root, you have 5. So the graph of this, again, since we're going both directions, you can have arrows here. The cube root function we say is kind of like our S function. So we have an S function there, and if I were to talk domain and range, since we have arrows going both directions for domain here, it's going to go from -infinity to positive infinity. And again, range is bottom to top, but it doesn't look like those arrows are pointing down or up. But again, remember that they're gradually going down or gradually going up. So range is the same, -infinity to positive infinity. So again, the biggest takeaway from this slide of your notes is to memorize the different parent tables for our different parent functions. So we're talking square roots and cube roots, 2 different functions, 2 different parent tables. All right, so when we had our parabola graphs and we talked about shifting, again, number 1 looks like it's going to be my parent function. When I jump to number 2, what happened with my parent function? What does that -8 in the back tell you to do? Hopefully you're thinking again to yourself, well, that's the k value. That's on the outside. There's no sets of parentheses, so that tells me I'm going to move down 8 units. So on the outside, that tells me down 8. Now in 3, this negative out front, if you remember what that transformation with a negative out front, this is what flips my graph. Again, here those parentheses pop up, and inside parentheses, we always think opposite. So if we're inside the parentheses connected to the x, hopefully you're thinking that this is going to move me left 6. And now in number 5, we have one with a number in the front. So again, on the inside, we think opposite, so we know we're going to go right 4. And on the outside here, this +5 means we're going to go up 5. But what does that number out front do? Hopefully you remember that the number out front is going to tell me on whether or not I stretch or shrink. So make sure that if you don't have this, that you get these jotted down here. Here we have all of these transformations that we've worked with before, but now we're going to have to use them when we graph our square roots and our cube roots. So make sure you pause if I went a little fast here. Write down especially what's in the box there so you have it again in these sets of notes. And let's try a couple examples here. All right, so here we go. Let's graph using these transformations. Again, let's break down what this equation is telling us. So under the root, this is what we're going to treat as our set of parentheses here. So anything under that root is going to be our parentheses. So in here, in those parentheses, we want to think opposite. Opposite of that -3 is going to move me right 3. And then this plus 4 on the outside, hopefully you're thinking we're going to go up 4. So again, we got to think about which parent table I'm using in this example. There's no index here, so we can assume it's a 2. That should tell you that's the first parent table we created. So if you think back or you look back in the notes, that would be the value 0, 1, 4, 0, 1, 2. So again, this table is where you get started. Now I take all of these transformations that we talked about here and I manipulate this table. So the right 3, again, since it's connected to my x, that's going to affect my x values. So to all of my x values here, I'm going to add 3. Because again, we're thinking opposite. I'm going to the right 3. This up 4 then on the outside, again, since we're going up and down, that would be affecting my y values. So I'm going to add 4 to all of these y values. I have no other transformations that we've talked about or that this equation is asking me to graph, so then I'm just going to graph, or I'm going to write my new table. So 0 plus 3 would be 3, 1 plus 3 is 4, 4 plus 3 is 7, 0 plus 4 is 4, 1 plus 4 is 5, 2 plus 4 is 6. So I take this new table I've created, I'm just going to go over here and I'm going to jot it down real quick. 3, 4, then we have a 4, 5, then we have a 7, 6. So again, this is our square root function, so it's only going to go one direction because under that square root sign, we can only have positive numbers. So we want to make sure that we're not going to extend arrows in both directions, but instead let's extend it to the right and say square root. And this right here would be our square root function graphed, and now we just need to talk domain and range. So again, domain is left to right, so my most left point would be 3, because it's my x values, and my most right point, again, since it has that arrow, would be infinity. So close bracket on the 3, open bracket on the infinity. Range then is bottom to top, so my lowest point, if I'm talking y values, would be 4, and my highest point, again, since I'm gradually rising to the right, we are going towards infinity, so I'm going to have infinity, and I'm going to open that bracket. All right, so now for a cube root example. Again, I know it's a cube root because of that index here, but let's talk about what transformations I have. This negative here is going to flip, and then the plus 5, again, anything under the roots here is what we consider inside those parentheses. So this is going to be opposite of that positive 5, so I want to go left. Now again, I want to think of that parent table that we came up with a little earlier in the video and think about, okay, cube root. Now this one's a little different than my square root. This one was the one that had those 8s in it. So I had -8, -1, 0, 1, and 8. And then I had -2, -1, 0, 1, and 2. So that again is your parent table that you talk about, or that we talked about earlier on in the video. And again, making sure you have that section of your notes next to you as you work through these examples will be really, really, really important. So now let's go forward and let's manipulate this table. Let's take all of these transformations that we talked about up here and move forward with them. Okay, so a flip. Again, if I'm taking something and I'm flipping it to the bottom of the graph, hopefully we realize or remember that this negative affects all my y values. So I'm going to multiply all my y values by a -1. And again, I'm multiplying because there is no plus sign between the negative here and the radical, okay? We can imagine that there's a 1 hidden in there. We don't always write our 1s, we know that, but there's no operation between that -1 and the radical, so we assume multiplication. The other one then again is left, and this H tells us to move left and right. If we're moving left and right, that's affecting our x values, so on all the x values, I'm going to subtract 5. And again, after doing this, I'm going to do a little bit of mental math to create my transformed table. So if I were to just do that mental math kind of quickly, -5, -4, and 3. 2 times, or -2, that would give me 2, 1, 0, -1, and -2. So again, taking those points and just plotting them. -13 gets a little bit off our graph, so we can imagine it's about over here. -6, 1 we'll put here, -5, 0 here, -4, -1, and Then we go all the way over to 3, -2. So again, this one looks a little bit different because it does go both directions because we can have negatives under our cube root function. So our cube root function is more of an S shape, but there are arrows on both ends because again, we can have negatives under our cube roots. So domain, as we think left to right, again, the most left point is going to be that negative infinity, and the most right point is going to be that positive infinity. Range is your y values going bottom to top, so your lowest point, again, it doesn't point down, but it's gradually going down, so your lowest point is going to be negative infinity. Highest point, likewise, is also going to be positive infinity. So again, jot down any questions you might have. I know this was a quicker video. It doesn't seem quick, but there's a lot of material in here. Make sure you jot down any questions you have because this is kind of important stuff, and we want to make sure that we understand this as we move forward and do the assignment. So I want to thank you for taking good notes, and I will see you when I see you.